Hi, welcome back to Dr. Abu's coaching classes. Today we will solve a circuit problem. This is a question from CBSE question paper 2025 February. Okay. Set number is 5511 and question number is 22. Here, two batteries of EMF 3 volt and 6 volt and internal resistance 0.2 ohm and 0.4 ohm are connected in parallel. This combination is connected to a 4 ohm resistance. Okay, so when we start doing this numerical, we want to get an idea about how will be the image of that one, the diagram of that one, because if you are able to draw a diagram, that will help you a lot. So in this question, after drawing the diagram, what you want to find is find the equivalent EMF of the combination, the equivalent internal resistance of the combination, and the current drawn from the combination. Okay. So, imagine two torch batteries of different strength wired together. What voltage does the pair act like? Will one battery charge the other? Let's find out. Actually, this is linked with a real life application. So, the key formulas what we want to use here. When two sources with internal resistances are connected in parallel, the equivalent voltage at the output terminal is the weighted average. I think you studied about the weighted average calculation. Okay, this is the CBSE marking scheme given. See, for this question, actually 3 part is there. So 3 mark is divided into 3, like 1, 1, 1. Okay, now we can enter into the solution part of it. So what we want to do first is, first you have to write what is given in the question. Maybe you want to read twice or thrice to understand what are the parameters given. From this question, you can understand there are two cells. So two EMF will be there. So EMF 1 is equal to 3 volt. Internal resistance 1 is equal to 0.2 ohm. The internal resistance of second one is 0.4 ohm. EMF of the second cell is 6 volt. And there is an external resistance here. The value of that one is 4 ohm. So we can draw one circuit which represent the situation. There are two cells, right? So let me draw two cells and they are connected in parallel. So I am drawing to connect them in parallel and also label their volt as well as the ohm values. Okay, resistance and EMF. Connected them parallel. Now connected to an external circuit. The value of the external circuit is 4 ohm. This much is clear in the question, right? Now we can enter into the answer part. So first part, there are 3 parts, right? So we want to find the net EMF, equivalent EMF. For that, you have to write the relation, weighted average equation, that is E1 R2 plus E2 R1 divided by R1 plus R2. Then substitute the values, 3 into 0.4 plus 6 into 0.2. That E1 R2 plus E2 R1 value. Below that R1 plus R2 value 0.2 plus 0.4 is equal to, upside first part will be 1.2 plus the other part also 6 into 0.2 will be 1.2 divided by the denominator 0.6. So numerator total 2.4 will come addition here and the denominator 0.6. So concluded now 4 volt. We will get 1 mark now. Now we enter into the second part. We want to find the equivalent internal resistance. Remember, there are two cells connected parallel, each having internal resistance. So parallel equation we will use, R1 R2 divided by R1 plus R2. So 0.2 into 0.4 divided by 0.2 plus 0.4. Okay, so it's equal to 0.08 divided by 0.6. Divide it and write the answer, 0.133 ohm. Now we enter into the third part of it. In third part, you want to find the current through the circuit. The equation for that one is total EMF divided by total resistance. Yeah. So total EMF here is 4 volt we calculated in first part, and below denominator external resistance is 4 ohm plus 0.13. So total answer is 4 divided by 4.13 ohm. So calculate it. It is close to 1, but actually it is 0.9 ampere. Okay. The final answer is, just for clarity, equivalent EMF calculated 4 volt, equivalent internal resistance calculated 0.133, current drawn from the combination also calculated, and how much it is? 0.9677. Approximately we can write 0.97 ampere. Now practice question. What you do this one is, pause the question, pause the video, write down the values and do in your notebook exactly what I explained. The same equation, same the method, only the values are different. So, and make sure that you are able to do this type of question if it asks next time. Okay. And after that, you can verify with the answer. I will post the answer in the comment box. And if you found this video helpful, don't forget to like, share and subscribe. Comment your doubts. Okay, I will cover them in the next video. See you soon.